Greetings and welcome, friends. Mr. Waddy here. We are talking about solving systems of linear, the most linear equations through substitution, which I think is an excellent means for solving systems, right? Excellent choice, really. We're on page 245. Question 5 here. They're not asking us to solve this system. They're just asking us for our target. All right, so tell which equation you would choose to solve for one of the variables. Explain. So when looking at these two equations and their two unknowns, x's and y's, which one would you aim for? Which one of those four choices? The first equation's x or y, or the second equation's x or y? Second y. Yeah, that's a good choice, right? You don't want to have to aim through all of this body armor with those coefficients. You want to aim for the weak spot, something that's got the -1 or the +1 coefficient. All right, so second y, and they said explain. Basically, it will avoid fractions if possible. It avoids creating fractions if possible. If possible. It's just going to be easier. Maybe someday I should have you guys try one of these problems and aim for the tough spot and just show you how inconvenient it is. But yeah, so aim for the weak spot. All right, solve the system of equations. Here we go, guys. Oh, I'm so pumped. Here we go. Notice for question 11 here, step 1 of solving systems is solve one of the equations for one of its variables. In this case, this first equation's x is got the weak spot, and it's already solved. Question 1 is done, right? So question 1 is done. It was already solved for that. I feel kind of weird with the variable being after it, but that's fine. So that was step 1. Sorry, I might have said question 1. Step 2 is substitute. So this is referred to as the revised equation, and this is the revised expression. I'm going to take this, and if it's truly equal to x, as it claims to be, then that means I could replace any x with that expression at any time. And so step 2, you plug this expression into the other most important, other equations x, and we'll solve for the remaining variable. So 3 times x, but oh wait, instead of x, I'm going to put parentheses 16 minus 4y, and then plus 4y on the outside equals 8. So the entire x has been replaced with this expression, as you can see. Now this equation is a little bit uglier than either of the original two, but it has one benefit, being that it is written all in a single variable. Yeah, there's only y's in this guy. There are no x's. Let's see, 3 times 16, I believe, is, nope, 48. There we go. 3 times -4y is -12y, and plus 4y equals 8. Let's combine some like terms. And yep, those y's are buddies if I ever saw some friends. -12y plus 4y is going to be -8y's. I'll bring this plus 48 over to this side. I'm just a fan of the variables going first, which really, that is typically what we would try to do anyway. So now get that y by itself, subtract 48. 40, I think it's, yeah, I believe that's 48 in Espanol. So -8y equals, -40. Ooh. And to get y by itself, it's not being subtracted by 8, it's being multiplied by -8. So the inverse operation is dividing by -8. Hopefully you guys are getting awesome at solving, right? I mean, we are a few chapters in now. That used to be the tough thing, but now we're solving multiple equations simultaneously. How amazing is that? So let's see. So I'll have y equals 5. But this is only half of the answer. So if y equals 5, what I will do is plug 5 in for y in the revised equation, the equation I had at the end of step 1. I prefer that choice because notice this equation is already solved for x. So yeah, that's going to make things a little easier. So x is equal to 16 minus 4 times, and instead of y, I'm writing 5, like so. And so x equals 16 minus 20, x equals -4. So my solution is the ordered pair -4, comma, 5. Let's do a check for this one. I might not do it for the other example. -4, comma, 5. -4, comma, 5. So if this is in fact the solution, then it will be the point, the only point that when plugged in for x and y that makes both of those equations true simultaneously. All right, so let's plug it into the first one, -4 for x and 5 for y. So is -4 equal to 16 minus 4 times 5? And let's just PEMDAS this. 16 minus 20, -4 equals -4. All right, so it works. It works in the first one. But there are infinitely many points on that line, that equation that line is represented by. So I need to make sure it works in the other one as well. Let's do that. So 3 times x, so that's going to be 3 times -4, plus 4 times y, 4 times y. When I repeat things, I feel like Sal Khan. He always repeats things as he's writing them. 3 times -4 is -12, plus 20. Is that equal to 8? Oh, no, you didn't. Yeah, we did. It worked. It works in both. Therefore, this is, in fact, the solution to the system. All right, lovely. Lots of steps. This is a big process. Lots of algebra going on. You got to be a solving expert to make this happen. Lots of also opportunities to make a mistake, and then unfortunately, if you make a mistake all the way up here, it carries through all the way the rest of the problem. It's kind of unfortunate, but when I'm grading and giving partial credit, as I do, if you make a mistake, I will then read through your problem as if that step was right to see if I can still give you the points that you need. All right, so the points that you earn, actually. So, question 15, where's the weak spot? What should I aim for? Which y or x? Yeah, the ones that don't have a number in front of it. So I could aim for this or this. Let's see, anyone have a preference? Either is fine. All right, I'm going to solve for x just because we've been solving for y for days due to slope-intercept form, and I'm just happy we finally can solve for x, right? Good old x. Everyone likes x. Let's see. X equals the opposite of y minus 3. So here's our revised equation. Let's do some substituting. Now, I solved for the second equation's x. That means when I substitute, I have to plug this into the first equation's x. All right, yeah. Boop, boop. There we go. So I'm plugging that entire expression in for x. So 5 times parentheses. Don't forget those parentheses, right? Don't just throw sand on a pedestal, right? We got to plug it in with the bag, keeping the sand together. Oh boy. Let's see, here we go. Distributing. So -5y minus 15 plus 2y equals nueve. Right, we're getting it, friends. Combining the likest of terms. -5y plus 2y, signs are different, so I'll subtract the numbers. 5 minus 2 is 3, and I'll take the sign of the more influential, which was negative in this case. Equals 9 My geometry students, when we've been solving systems, when they show up in the middle of a geometry problem, they're just like so happy to be back with algebra. It's like nostalgic for them. What's that going to be? 24. This guy, for you guys, it's all new and it's different and unusual, but for them, it's like wonderful and comforting. It's like, yeah, my wife made shepherd's pie last night. It was just like delicious comfort food. I was just like, I told her, she was mad at me earlier this week. I was like, you got to stop making me fat. And she's like, no, that's your fault. I'm like, you got to stop making delicious food. And then she serves me some small portion. I'm like, no, I'm going to go back for more. This is too delicious. You're right. I'm the one making me fat. Boy, alas. But if I just never allow myself to buy larger clothes, then I have no choice but to eat less. Right? I don't know. So, all right. Yeah.
Like I've had, I don't know how long.
Yeah. I was sad this morning when I ironed my pants and then I went to iron my shirt. My shirt had like mouse chewed up collar and I was like all sad about that. So now I've got to like figure out where this mouse is getting in my closet. That jerk of a mouse. Let's see. So I've been doing a lot of substituting and talking about mashed potatoes and corn and beef and clothes and mice. Yeah. So here's our solution, right? At the end of step 2, once I solved for y, I plugged it back into the revised equations y. Careful of those double negatives, friends. Substitution, use those parentheses. And I'm not going to bother to do the check for this one. Actually, maybe I'll do let's do a Desmos check. Desmos, the calculator. All right, so here's our Desmos graphing calculator. Oh dear, here we go. All right, and let me scroll up. So let's see, 5x plus 2y equals 9. 5x plus 2y, that's a 6, equals 9. All right, there's one line, and the other one was x plus y equals -3. So the nice thing about Desmos is it doesn't even need slope-intercept form. All right, so here's the graph of our lines, and the intersection of these lines will be the common solution of both of them, and it looks like that is right here. I hope that was my solution. Was it 5, -8? 5, -8. It was. Oh, phew. That was close, guys. All right. So there you go, friends. Instead of solving by graphing, we now know how to solve by substitution. Yes. Excellent. All right. Have a great day, Internet friends.